Good day, grade 8 students. So for today, we are going to start solving problems involving quadrilaterals. So the first quadrilateral that we have here is a parallelogram. Okay, so from the word parallel, a parallelogram. So a parallelogram has two pairs of parallel sides. Okay, so for this one, for parallelogram palm, okay, so we have here parallelogram palm. Okay, so we have here sides AL, okay, sides AL and PM are parallel, and also sides PA and LM are parallel. Okay, so let's try to solve for the value of x here. Okay, so again, we have the property of a parallelogram. The opposite angles are congruent. Okay, so this 3x minus 9 angle P, and angle L are congruent. So we can equate them. Okay, so this will be 3x minus 9 is equal to 84. And then 3x will be equal to 84 plus 9. And then 3x is simply 3x 84 plus 9, that will be 93. Okay, so 84 plus 9, 93 divided by 3. Okay, so the answer for x is equal to 31. Okay, now let's solve for y. So the opposite of y, okay, so the opposite of y, the 2y plus 6 angle here, angle M, its opposite is angle A. So we can equate them since the property of a parallelogram is that the two opposite angles are congruent. So that will be 2y plus 6 is equal to 96. And then 2y will be equal to 96 plus 6. Oh, this is plus 6, right? If you transfer it, it's going to be minus. Okay, so that's going to be 2y is equal to 96 minus 6. So that will be 2y is equals to 90, and 2y divided by 2 and 90 divided by 2, the value of y is 45. Okay, so there. And therefore, we can now substitute the value of x and y in order to get the measurement of the sides here, because we have, as you can see here, side PA and then side AL are measured in terms of variables x and y. So how do we do that? How do we solve them? So we have here the value of x. The value of x is 31, okay, and the value of y is 45. Okay, so y is 45. Now we can solve for the side measurements of PA and then AL. So PA will be equal to 14x over 4 centimeters. Okay, so what's 14 times 31 over 4? 14, okay, so 14 times 31, okay, divided by 4, so that's going to be 217 over 2, or 108.5. So side PA measures 108.5 centimeters. So how about AL? Okay, so AL is equal to 9y. And we just simply multiply 9 by 45. So what's 9 times 45? 9 times 45 is 405 centimeters. Okay, so there. We found the measurements of side PA and side AL. And if you want to find the measurement of side LM, so it's just going to be equal or congruent to side PA. So that's just going to be the same as side PA. And also for AL, if you want to find the measurement of that side, it's just going to be the same with side PM. Okay, so very easy. Okay, so we have here a very large figure. So let's try to make it a bit smaller. Okay, there you go. Okay, so let's try to solve for this problem that we have here. So we want to find the measurement of angle A and angle B, and also the value of x. So how do we do that? How do we solve for that? Okay, so we have here 2x minus 3. Okay, so if you see, guys, if you see here, its opposite is 103 degrees right here. So if its opposite is 103 degrees, or they are vertical angles, okay, so the vertical angle of 2x minus 3 is 103 degrees, therefore we can equate them because they're vertical angles, they are congruent. Okay, so that's going to be 2x minus 3. Okay, 2x minus 3 is equal to 103 degrees. So what's our next step? So we have to transpose the value of negative 3 here. So if we transfer to the other side, it's going to be positive 3. So 2x is going to be equal to 106. And if you divide that by 2, okay, x is equal to, so it's 106 divided by 2. That's 53. So the value of x there is 53. Okay, so we solve for that one. Now comes the much more, a little bit difficult, but we can solve it just by using a bit of algebra part. Okay, so we want to solve for the values of angle A and angle B. So how do we do that? Okay, so we already know guys that the measurement of this angle of 2x minus 3 is 103 degrees. Yes, so it measures 103 degrees because we have already solved it. And also, it's a vertical angle of 103. And we have here a line. Okay, so if you remember, on our linear pair postulate, the supplementary angles right here, these two angles right here are supplementary. Therefore, we can get the measurement of this angle right here. Okay, and also we can even get the measurement of this angle right here. So maybe let's just try to get the measurement of the angle right here. Okay, so this one first. Okay, so that's going to be the measurement of this angle. Okay, so that's going to be 115. Okay, so that's 115. So we have to minus that from 180 degrees. So why did we minus that to 180 degrees? Because that's a straight line. Okay, so that's 180 minus 115. So it's 180 minus 115. That's 65 degrees. Okay, so the measurement of this angle right here is 65 degrees. So then we can get the measurement of this angle, of this one. This angle B here, okay, because we already have the measurement of this one, 103 degrees, and we also have the measurement of this one, 65 degrees. So how do we get the measurement of angle B? So we just simply, since this is a triangle, the measurement of a triangle is 180 degrees, we just simply minus 180 from, minus 103, and what do you call this? 103 and 65 degrees from 180 degrees. Okay, so the measurement of angle B is going to be 180 minus 103 minus 65. Okay, so that's simple because we already solved for this angle and 103 degrees is given. So that's going to be 180 minus 103 minus 65, so that's going to be 12. Okay, so the measurement, so the measurement of angle B, the measurement of angle, so let's try to write that again. The measurement of angle B is 12 degrees, okay? And also, since the measurement of angle B, the measurement of angle B is also 12 degrees, then angle A is also going to be 12 degrees, okay? The measurement of angle A and angle A is also 12 degrees. So how is that? So if you look closely, these two lines that we have here, these two lines that we have here are parallel lines, this one and this one at the bottom. So they have markings there that signify that they're parallel lines, so they're parallel. And when you draw a transversal between those two parallel lines, the alternate interior angles are going to be congruent. And it just so happens that angle A and angle B are those two interior angles that's been drawn in these parallel lines and the transversal. So that means angle A and angle B are the same. They have the same measurement. Or you can simply try to draw an analogy. So it kind of looks like a Z, whatever angle that falls in the Z, in this Z figure, or like a vertical or a, what do you call this, an upside down Z, or a vertically flipped Z. So we get the same measurements for both of the angles. Angle A and angle B are congruent and their measurement are 12 degrees. Angle A and angle B measures 12 degrees and the value of x is 53. So let's move on to our next problem. We have here an isosceles trapezoid. So for this isosceles trapezoid, we want to find the measurement of this value right here, angle U. So angle U measures 3x minus 15 degrees. So it measures 3x, angle U measures 3x minus 15 degrees. So how do we solve this? How do we solve the value of x? How do we solve for the value of x? So what we have to remember, guys, for isosceles trapezoid is that their base angles are congruent. So if angle E if angle E measures 105 degrees, then angle L must also measure 105 degrees. But we only have here 47 degrees. So how do we get the measurement? The measurement of this angle right there. So what we have to do here, okay, to get the measurement, okay, so let's use a white pen. Okay, so to get the measurement of angle ULX, what we have to do here is we have to minus 105 from 47. Okay, so why do we have to do that? Because again, the measurement of angle L is 105 degrees because it's congruent to angle E. So it's just logical, or it follows that we have to minus 47 from 105. So it's 105 minus 47, you get 58 degrees. Okay, so the measurement of angle ULX is 58 degrees. So we can write that here so that we don't forget it. So we have here the measurement of angle ULX is 58 degrees. Okay, so we have one angle down here, so that's 58 degrees. So we just need to solve for the value of angle UXL. Okay, so we have this angle right here, so that we can try to find the measurement of angle U. So how do we find the measure of angle UXL? So there's an angle that's adjacent to UXL, and that's LXE, and LXE measures 176 degrees. So how do we get the value of UXL in relation to the adjacent angle, to its adjacent angle? So we do that by just simply minusing the measurement of a straight line. Okay, since this is a straight line, we minus, okay, we get the measurement of a straight line, which is 180 degrees. 180 degrees, and you minus that to the measurement of angle LXE, which is 176 degrees. Why? So that we can get the measurement of this one, of angle UXL. So what's 180 minus 176? So that's simply 4 degrees. Okay, so the measurement of angle UXL, angle UXL is actually 4 degrees. And therefore, we can get the measurement of angle LUX, of angle LUX. Okay, so to find the measurement of angle LUX, angle LUX, so angle LUX measures 3x minus 15 degrees. We already solved for the value of angle L, of angle ULX. Okay, so that was 58 degrees, right? So right there, 58 degrees. And you also solve for the value of angle UXL right here. There you go. So it's 4 degrees. So here the measurement of angle ULX, and the measurement of angle ULX is 58 degrees. Okay, so we have there 58 degrees, and also we have the measurement of angle UXL. It's 4 degrees. Okay, so we have those two angles already. Yes, so we can already solve for the measurement of angle. Okay, angle UXL measures 4 degrees. We can measurement for the measurement of angle LUX. We can solve for this angle. So how do we solve that? Okay, so we have to equate it to some value. So that value is going to be 180 degrees. Why? Because we have here a triangle. Okay, so since it formed a triangle, okay, and then the measurement of angle ULX is 58 degrees, and the measurement of angle UXL is 4 degrees, then we can equate it to the measurement of a triangle, which is 180 degrees. Okay, so that's going to be, 3x minus 15 plus 58 plus 4. So what's 58 plus 4? So that's going to be 62. Okay, so that's going to be plus 62 is equal to, so that's just 58 plus 4, okay, so you don't get confused, is equal to 180 degrees. Okay, so the next step is we have to transpose the value of 62 to the other side. So this is going to be 3x minus 15 is equal to 180 minus 62. So what's 180 minus 62? We have 118. So 3x minus 15 is equal to 118. So that's going to be 3x is equal to 118 plus 15, and 3x will be equal to, okay, so we have here 3x is equal to 118 plus 15, so that's going to be, okay, plus 15, so that's going to be 133. Okay, and 3x, okay, free x is equal to 133. Okay, so free x is equal to 133, and if you divide that by 3, you get x is equal to 133 over 3, or that's going to be 44.33. Okay, so we found the value of x. So now we can get the measurement of angle u. So angle u measures, again, angle u measures 3x minus 15. Okay, so that's going to be 3x minus 15, and then we have to substitute 3. We have to substitute the value of x, which is 133 over 3. Okay, so this is the one that we all have to substitute because it's a fraction. Okay, so this is the measurement. This is the measurement of angle u. Okay, so the measurement of angle u is equal to 3 times 133 over 3. Okay, so that's going to be 3 times 133 over 3 minus 15. And then the 3 here cancels out, so that's going to be the measurement of angle u. It's going to be 133 minus 15. Okay, so angle u. Okay, what's 133 minus 15? Okay, so that's going to be 118 degrees. And therefore, we have found the measurement of angle u. Okay, so that's simple. Okay, so let's move forward with a kite. So for a kite, guys, the measurement of the sides, the adjacent sides, are congruent. So we have their 5m and its adjacent side is 46 centimeters. And we have their 3 over 59 and its adjacent side is 18 centimeters. And also another property of a kite is that their opposite angles are congruent. Okay, so let's try to solve for these values. Let's try to solve for the value of m, the value of k, and the value of n. So first, let's start with m. So 5m should be equal to its opposite or to its adjacent side. Okay, so the adjacent side of 5m is 46. So that's going to be just simply divide by 5. Okay, so m is equal to 46 over 5. Okay, so let's keep it that way. And also, we want to find the measurement of angle n. So the measurement of angle n is going to be 3 over 59n is equal to 18. Okay, because it has to be equal to its adjacent side, which is AD, or 18 centimeters. Okay, so that's going to be, we have to multiply the reciprocal of 3 over 59 to the entire term so that the 3 over 59 cancels out. So that's going to be 59 over 3. So we cancel this one here. And you are left with n is equal to 18 times 59 over 3. So we have a 3 here. Okay, so we can cancel this one. So we have here a 1 and we're left here with 6. And what's 59 times 6? 59 times 6 is 354. So the value of n is 354. So we solve for the value of m. We solve for the value of n, which is 354. We solve for the value of m, which is 46 over 5. Then we can now solve for the value of k. Okay, so this one is going to be easy since the opposite of angle u is angle A. Then we can simply equate them. So that's just going to be 9k minus 12 is equal to 123. And the next step is going to be, we have to transpose this value to the other side. So that's going to be 9k is equal to 123 plus 12. So 123 plus 12, that's going to be 135. Okay, so 9k is equal to 135. And if you divide that by 9, so the value of k is going to become 135 over 9 is going to be 15. Yes, the value of k is 15. Okay, and if you substitute the value of k there, so that's going to be 9. Okay, so that's going to be 9 times 15, right? Because that's 9k. So that's going to be 135, and minus 12 you get 123, which is its opposite angle. Okay, so there we got the value of m, the value of n, and the value of k for our kite there.